I get asked a lot about, if I would let my children play football. And I would. I don't think we have enough evidence to suggest that the harms outweigh the benefits yet. If you said, would I be worried about brain health and my child or family member who played 10, 15 years in the NFL and sustained 150 concussions or bell rings? I would be worried about their brain health over time, right? But that's a very different question than letting, little Tommy play Pee Wee football.
Welcome to Learning from Leaders, a podcast from Southwestern Medical Foundation where we dive into a world of wisdom, mentorship, and innovation, exploring the insights and life lessons of seasoned community and business leaders. I'm Michael McMahon, President and CEO of Southwestern Medical Foundation. I invite you to subscribe now and join us on this empowering journey of growth and leadership. Now, let's learn from the best and drive meaningful change together.
Hello and welcome. You're listening to the Learning from Leaders podcast. I'm your host, Lili Clark, and our guest today is Dr. Jeff Schaffert. Dr. Schaffert is an assistant professor at UT Southwestern Medical Center's Department of Psychiatry. In 2025, Dr. Schaffert was awarded the Cary Council's $50,000 early stage research grant as one of the council's doc stars, supporting his pilot study using blood biomarkers, neuroimaging, and cognitive testing to detect early signs of decline in former collegiate athletes. Dr. Schaffert, congratulations on the grant, and thank you so much for joining us today.
My pleasure.
So to start off, we'd love to hear just kind of generally what your research has been focused on. In particular, what are you hoping to get out of the Cary Council's grant?
Yeah, well, thanks for having me on. So I've been interested in repetitive head impacts and how concussions in athletes and also in civilian populations, we call them civilian populations, impacts later in life neurodegenerative disease, including dementia. So what we're hoping to get out of this pilot funding from the Cary Council is a preliminary data looking at specifically middle-aged collegiate football players, trying to get a sense if we can understand, is there any early stage cognitive difficulties that may be subtle and they're not picked up on just in normal everyday life, in addition to any type of brain marker we can find in this population. So we have ways of getting at proteins that may be accumulating in the brain. We can now test those through blood, and there's new emerging technologies where we can get even after I had put the award in or put the grant in and then was notified of the award, there's new technologies already out that allow us to do more multiplex panels that will be very interesting to look at. And we're also going to do some imaging as well, some advanced diffusion imaging to see if what the white matter or the connection and support cells of the brain are, if there's good integrity of those systems or not, or has the impact of repetitive head impacts really cause some degeneration of those pathways.
Okay.
So,
and we'll get into it a little bit more, but
sure.
I kind of wanted to start and just hear a little bit about what this grant from the Cary Council has kind of meant to you personally, professionally, and so on.
Excuse me. Yeah, I'm extremely grateful. This is the kind of funding that we, as early career researchers, really need. The ability to get some seed funding because a lot of people don't realize this, but in order to really be competitive with larger NIH or NIA grants, we really need some pilot data in order to kind of demonstrate feasibility.
Right.
For one, like we can recruit these participants, and we have some interesting data that kind of generate some additional hypotheses and questions. So it's critical for us to really get at or to receive pilot funding like this so we can accomplish that first step. And especially in today's funding environment, it's very competitive, and it's really helpful for us to hit the ground running, so to speak.
Yeah. So a lot of our listeners either were athletes themselves, maybe they're athletes now, maybe they have kids who are athletes. Could you talk about why this research matters to someone like that, or to our listeners? We'd love to hear your thoughts on that.
Of course, yeah. Well, there's a lot in the news. So I'm an athlete myself. I would say I was a baseball player. I caught my fair share of some dings to foul tips off my catcher's mask and so forth. But yeah, so there's a lot out there in the media right now about the impact of repetitive head, what we call RHIs, repetitive head impacts. They're not quite concussions. They're what they call subconcussive hits, right? So these are below the threshold of clinical detection. So if somebody gets hit, they may not really feel woozy, and they may not really feel like there's been a concussive injury. They don't have dizziness or nausea, they don't lose consciousness. Those would be more symptoms of concussion. Those are important, but our research is really trying to get a sense of what is the actual risk of just the long-term exposure of these kind of mini hits or repetitive head impacts that we would say. So we're looking specifically at this age range of kind of middle age and collegiate football players. There's been some research, certainly through Boston University and the CTE Legacy Foundation and all of that, really focusing on the NFL and professional football players. But there has not been nearly as much research in college, and there has not been nearly as much research in high school football players. So we're trying to, that the NFL represents probably 0.01% of all football players, right? So it's from a risk stratification standpoint, we really don't have a good idea of what the risk is for more collegiate players. So that's one of the goals behind the project, is to really look at higher level amateur players. Okay. But we also have to have it be enough of a repetitive head impact exposure to really show if there is any signal there. So instead of going to Pee Wee football players or high school football players, this seems to be somewhat of a happy medium in that regard, if that makes sense.
So how are you going out and recruiting participants?
Right now, it's a lot of word of mouth. We just put the IRB, or Institutional Review Board for ethics approval, to do the study. And so the plan is to recruit from word of mouth, in addition to flyers, in addition to, we have an ongoing study already that's funded by the Delcare Royal Foundation. And that's also looking at collegiate players, including all athletics, not just football players, but we have big email servers now that we can kind of blast out and use some social media recruitment strategies. It's a small study. We're looking for 20 football players and 10 non-football players who also haven't had a history of concussion. So that way we can get a comparison group to see if there's significant differences between the two. And so I will be recruiting some of my old collegiate baseball buddies to try to help help with that, a little bit of word of mouth for our control group as well. So it's going to be somewhat of a grassroots effort to really make that happen.
So for listeners who maybe haven't participated or had much exposure to studies like this, walk us through what exactly happens once you have the participants recruited, they come in, they're ready for the study. What exactly are you measuring? Mm-hmm. How long are they spending with you? Is this over a handful of months or days?
Yeah,
tell us everything.
Yeah, it'll be 2 days. One of the days will be virtual, and the other day will be an in-person visit. We also will do some red cap surveys that they can kind of complete questionnaires at their leisure online. We really want to minimize the amount of time that people need to spend. These are 30 to 50-year-olds, participants. They have jobs, they have families. We don't want to spend multiple days on end taken away, and we want to make this as easy as possible for them. So if you're a eligible participant for the study, we'll come in, we'll do an initial screening to make sure that people are eligible, they can undergo an MRI, that kind of thing. And then we'll do an interview. So I will be asking questions through a virtual interview, and I'll be kind of collecting all of this data to get a sense of really detailed contact sports exposure, how long they played, what the practice times were, how many contact practice times you had. And that way we can get a total estimate of repetitive head impact exposure. It's very difficult. Otherwise, it's just simply, how long have you played? because there's not a lot of data out there on what the best ways of really measuring this.
Right.
Because technically any hit to the head that doesn't cause a concussion is a subconcussive and repetitive head impact. So we really need to be very detail oriented about that. So the first is getting an interview of all that, and then we're going to give out some symptom questionnaires that they can complete. And then we do the in-person evaluation. They'll come in and we will do detailed neuropsychological testing, which is really neurocognitive in this case. We're really trying to see, is there any subtle difficulties we see in processing speed or memory, or what we call executive functions, which are like problem-solving abilities. And so we have norms to be able to detect, is that below normal for somebody that age level? And so we will do that, and then we will do a blood draw.
Okay.
And the blood draw is really to look at now new technologies of plasma biomarkers to know what's going on in the brain. So we can test for neuroinflammation. We can test for the beginnings of tau deposition, which is really important in CTE.
Can you talk about what that means?
Yeah, tau. Yeah, tau is a protein in the brain that collects. And once it collects, and so for example, a lot of people know about tau from Alzheimer's disease. It collects and can form plaques and tangles together and causes the cell to die in neurodegeneration.
Okay.
It's linked very strongly to cognitive impairment in Alzheimer's disease. And there are several tauopathies, they call, like different brain diseases, and CTE is one of those. We don't have a good biomarker to specifically tag CTE neuropathology yet. But in this case, if we see tau in brains of 35 to 40-year-olds, it really shouldn't be there. And so we're also going to try to link these types of proteins to the amount of exposure to see if there's a direct link between the degree of and exposure of repetitive head impacts and the deposition of these proteins. I think that the degree of tau is probably going to be, the frequency of that is probably going to be pretty low in our population, but I do think there's probably there's cascades that kind of lead up to that, and neuroinflammatory markers for one, and that way we can really test that. The other thing that we'll do is an MRI. And that MRI, we're going to kind of catch a broad, net. We're going to look at cerebral blood flow. We're also going to look at white matter integrity, as we say. So these are the connections in the brain that sometimes, for example, in traumatic brain injury, when somebody has a hit, the brain tends to rotate in the skull and can cause some shearing injury. So these are like the highways in the brain. They're longer track neurons, and they provide some structure, but their main goal was really to facilitate communication between cells, and degeneration of that can cause some cognitive problems, or it can be a precursor to cognitive problems later in life. So we're going to be testing that as well.
Okay.
So we're catching a lot of data in a very short amount of time.
And then what do you hope will be like the outcome of the data? Like, are you using it to go to team physicians and say, this is how you can prevent future degeneration, or is it something that's focused on like solving later in life issues? Like, how do you plan to use the data?
So I'll say there's primary goals and short-term goals of this particular study, and then there's long-term goals. Our primary goal and short-term goal of the study is to assess if there's any signal, whether it's large or small, between collegiate football players and non-collegiate football players on these brain injury markers, essentially. We can then use that data to generate more hypotheses and test more athletes to get a better and be more confident of these findings. When we're dealing with small sample sizes, there's some variability sometimes. So that first, when we see 20 against 10 people, it's really more hypothesis generating at this point. If we can confirm these findings and find that, there is a degree, for example, of repetitive head impacts that place people at risk of neuroinflammation or other or active neurodegenerative process that are now, essentially 10, 15, 20 years from their football career, how much is too much? Is there interacting factors involved? And then we can actually start stratifying and understanding this risk a little bit more. Because right now, if you have said, well, how much exposure is too much exposure of football or boxing or any other like major contact sport, we couldn't really tell you that. We just say, oh, it's not, obviously, I think everyone would agree it's not good to have multiple concussions or brain injuries to your brain. But the literature is really quite mixed in terms of what the risk actually is of playing contact sports.
Yeah.
Especially when it comes to later in life. We're trying to study things that happened 30 years ago and understand the risk of dementia, for example, which is already a high frequency condition.
Right.
So we don't know if that's a direct link of that or there's a causal relationship. We really need the biology and these kind of studies that really look at, okay, what happens 10 years after your football career first before we get to 20, 30, 40 years later.
Yeah, that's super interesting. Like, how do you isolate like the correlation of the sport
one study at a time
to the issue? As opposed to all of these probably thousands of other factors out there in the world.
There's lots of factors that lead to dementia. There's lots of factors that really probably mediate or moderate or attenuate this relationship. And we're trying to really just get some baseline data. We have yet to see large-scale studies of collegiate football players that have undergone multiplex neurodegenerative panels or neuroinflammatory panels and other white matter and advanced imaging techniques.
Yeah.
So we're casting a wide net with this pilot data.
Okay.
Learning from Leaders, along with Southwestern Medical Foundation, is powered by generosity. Your support can help fuel breakthroughs in medical research, provide critical patient care, and support medical education. Additionally, it helps support the Learning from Leaders podcast and content like this. Every gift matters. Consider making a contribution today at swmedical.org/give. That's swmedical.org/give.
You've already done published some research about the tie between traumatic brain injury leading to Alzheimer's. Could you talk about what do we already know out there, and then what is left to decipher?
Yeah. Well, if we're going to be talking about, we'll start with traumatic brain injury, which would mean anywhere, and that's a very heterogeneous condition. So traumatic brain injury could be a concussion, which is a mild TBI or mild traumatic brain injury, to severe, leading to coma and death, right? So there's a big range of severity of injury in there. And even some have argued that sports concussion injury is different than like if you have a mild TBI from a car accident, which maybe has more force. Like it's really hard to measure, the degree of injury on that. So we'll start with just saying there's mild and then more than mild or moderate severe injury. Moderate severe injury is an established risk factor for the development of dementia. And dementia being that we have severe enough cognitive impairment to interfere with somebody's ability to do their daily living tasks. So they can't drive on their own. They can't do medications on their own. We're all familiar with kind of what the phenotype of dementia looks like. But there's different causes of dementia, and they all have different proteins that build up. And one of the main causes is Alzheimer's disease. So we've done a lot of work in understanding what's the risk of brain injury and the development of Alzheimer's disease, for example. Moderate to severe is a more established link. And it could be that the actual injury itself leads to the deposition of Alzheimer's proteins in the brain through an injury cascade. That could be it's likely, we don't know for sure, but our hypotheses are these are probably static depositions. They happen one time after an injury. And then over time, as somebody ages and those proteins build up anyway, they have a lower threshold before they hit symptoms leading to an earlier onset.
Right. Okay.
So we found a lot of evidence to suggest that if you have a brain injury, that your chances of getting Alzheimer's disease earlier are higher. So you have an earlier onset in general. And there is higher risk of developing dementia. In mild injuries, meaning those without loss of consciousness or concussions, that link in multiple studies and large databases throughout the world and Europe are really mixed.
Okay.
So we don't have a good sense of mild injury being a predominant risk factor of dementia. So, but that again is probably likely to a lot of these studies focus on public record data that come in from medical evals.
Yeah.
So you're only probably diagnosing the more severe end of those concussions, right? Those that may have skull fractures even, and more prolonged loss of consciousness, not necessarily somebody who fell and hit their head and, said, oh, I'm fine, and didn't really go into the hospital. So we're probably missing the lowest end severity of that. And so that's why I think some of this mixed findings are probably coming from. So moderate severe is more established. Mild is somewhat mixed in terms of, is it a really strong risk factor or not? And then we get to the repetitive head impact side, which is more about not necessarily the number of actual injuries, but just the number of head impacts that accumulate over time.
Yeah.
So that's a little different. Those are the subconcussive injuries.
Okay.
And so that is even more all over the map, we would say, in terms of risk profiles. How much is too much? Is it because it is a combination of both the repetitive head impacts and some sort of other factors like genetics that may be playing a role? We just don't have a lot of good answers to that right now.
Okay. Well, I'm sure you're asked a lot by families and parents. Like, what do you advise them when you're trying to, weigh the risks that we talked about, but also all of the benefits of sports?
Yeah, I think there's a lot of benefits to sports. And I think I get asked a lot about, I have 2 girls, so I don't have a boy yet, but if I would let my children play football. And I would. I don't think we have enough evidence to suggest that the harms outweigh the benefits yet. It's possible that changes, and that's a different question. If you said, would I be worried about brain health and my child or family member who played 10, 15 years in the NFL and sustained 150 concussions or bell rings? I would be worried about their brain health over time, right? But that's a very different question than letting little Tommy play Pee Wee football, right?
Yeah.
So it's not the same. So I think there's a lot of benefits to sports, right? Social interaction, leadership, the team dynamic of that. I think it also teaches discipline, and especially as you get more involved in higher level sports, like the dedication to the sport and the commitment. There's a lot really of benefits to that. And the number one thing that we can do to protect our brain over time is to exercise regularly and eat good diet.
Right.
So with the sports, that obviously is built in.
Yeah.
Right, with of part of training. So I think there are a lot of benefits to it, and it's not as simple of a question of, yes or no, would you do that? I think it really depends on the circumstances.
Yeah, and more about finding ways to mitigate the risks.
Yeah, absolutely. Certainly there are new helmet technologies coming out trying to reduce the risk of concussions. There's obviously rule changes in the sports. You can play flag football earlier on before moving to contact football. So I think there's lots of things that we can kind of do to try to mitigate risk, and I think those are valuable efforts. You really, though, we don't want to create we don't want to scare anybody,
right?
When we're talking about these issues, because I think we have to take a very balanced and nuanced approach of what we know and what we don't know.
So this is a little bit of a side note, but it circles back, I promise. So for any listeners who might not be aware, Texas at the state level just approved DPRIT, the Dementia Prevention and Research Institute of Texas. Could you talk about how this impacts your work and other researchers who are in your field?
Well, it'll keep some researchers in Texas, and we'll probably draw some in. It's amazing, that amount of support. $3 billion, I think, is the number. It's an amazing amount of funds and money, and certainly support for dementia research. We've already seen a really big return on investment through our Texas Alzheimer's Research Care and Consortium as well. I think this is going to be that on a much larger scale. We don't have all the details yet about how the funding is going to be allocated, and where is it going to be more for early career researchers, or more senior faculty and other institutions. So, but I imagine there's going to be a lot of pilot and support for early career researchers. And I think that is critically important, as we kind of talked about the same thing with the Cary Council. But it's important for us to keep our researchers, funded.
Definitely.
Because discovery is going to slow significantly if we don't have that funding. Alzheimer's disease is and dementia in general, regardless of the type, is an extremely costly, devastating condition for patients and families, and really we're hoping that we can get more and more treatments out there. So there's lots that we can use this funding for.
Yeah. What do you think is the biggest thing about brain health that people either don't know or realize or is misunderstood?
Yeah, really good question. So the Lancet comes out with 13 modifiable risk factors for dementia.
Okay.
And there's several of them. I can't list them all off the top of my head, but there's exercise, controlling your cardiovascular risk factors, so controlling your blood pressure, controlling your diabetes. There's eating a heart-healthy diet, avoiding smoking, avoiding alcohol intake. So all of these things, what the research suggests is that a sizable minority, so probably 30 to 40%, if we controlled all of these risk factors, could be prevented, as far as dementia cases could be prevented. So it's a huge brain health, and actually using the modifiable risk factors we have can actually help prevent dementia from even developing, because it's likely a synergistic mechanisms that really develop or really cause the cell loss and neurodegeneration, I should say. So that's a main thing. And the other thing is that it's not too late just because you're in your 60s to really start making changes for your brain health. I think that's somewhat misunderstood too. Even in patients that already start having cognitive impairment, which we would call mild cognitive impairment. So not normal aging, not dementia, but somewhere in the middle where they're starting to show memory loss. Even in patients where the disease process has already become symptomatic, you can slow that progression significantly with exercise and diet. And there's a lot that we can actually do. We talk a lot to our patients about brain health when they come in for evaluations.
So zooming out a little bit on your career.
Okay.
So you've been at UT Southwestern for a handful of years. Obviously, UT Southwestern is a leader in brain health. For any listeners who aren't aware, the O'Donnell Brain Institute is investing significantly in this space. What brought you to UT Southwestern and to Dallas? What was your journey here?
That's a good question. So I'm from Michigan originally, and I went to actually go play baseball down in the South, and then I went back up to Michigan for my master's degree. And so I got my master's degree, and then I applied. UT Southwestern was a great place for a clinical neuropsychology program, for a clinical neuropsychology student to train. And so I applied here, and it kind of worked out great. My wife is from this area, and so we got to come back next to family. And so I've been here starting in grad school in 2016. That's when I started, and then I achieved my doctorate in 2020, and then did my 2-year fellowship in neuropsychology and research starting in 2020 and then ending in 2022. So I've been here in Dallas and UT Southwestern for going on 9 years now.
Nice.
It'll be 10 years in next fall.
Okay, well, congratulations in advance.
Yeah, so it's a great institution and like from a training perspective, but also just the amount of support that we can receive. So in addition to the Cary Council, for example, we have also the Dedman Family Scholars Program, which I was very fortunate to receive funding in as well, which is going to support things for multiple years to really kind of launch a more established research career. So lots of reasons of why we want to stick with UT Southwestern.
Yeah. Can you talk more about the Dedman Family Scholars Program? And congratulations on that,
thank
too.
You. Yes, thank you very much.
Talk more about what that has meant for you.
Yeah. Oh, my gosh. So it's an amazing amount of funding, and I'm so grateful for the opportunity. This is in a different line of research. It's in the dementia field, but it's more specific to a condition called normal pressure hydrocephalus, which is a very interesting subtype of dementia that we don't really know a lot about, that we're trying to understand what's causing it and what's driving the cognitive symptoms in these patients.
What differentiates this type of dementia from others?
Yeah, well, one, it's treatable. So it involves a buildup of cerebrospinal fluid in the brain. Our brain is full of spinal fluid. It surrounds the brain and cushions the brain. For whatever reason, either the process of production or the drainage process becomes chronic over time in older patients, or becomes dysfunctional, and it's a chronic process over many years that happens. And in this subtype, patients develop problems with walking, they develop urinary symptoms, and they develop cognitive impairment. And my research in this area is really trying to understand what's driving the cognitive impairment in a very similar modality of using blood and CSF and these biomarkers to really try to understand what's going on in the brain. So that's it's been and this year it was a partnership with O'Donnell Brain Institute to provide funding for a brain injury type of researcher, which is why I was selected this year, which was great.
Okay. So you have all of these research initiatives going on. You're also seeing patients. Can you walk us through a typical week? Like, how are you thinking about...
I don't think there's a typical week.
Okay, no such thing. How about this week?
Okay. Oh, well, okay. So, the life of a clinical scholar is basically what you're asking. So this week, we have certain days are kind of more research days, and certain days are more clinical days. We can kind of break it down that way. But I don't normally go on podcasts on Friday afternoons either. So, but yeah, this week it was a lot of writing this week, trying to prepare a big submission for a big grant, an early career investigator grant. So a lot of writing this week. I saw patients in the hospital. I saw patients in clinic. A lot of patients have had normal pressure hydrocephalus. It's kind of more clinical, where most of my clinical time is devoted now. But then you have patients come in for any type of question of neurologic disease and cognitive decline. And so they need an assessment to really understand how much cognitive decline is going on, what is the most likely diagnosis, or what's the source of that, and what's anything we can do about it. So that's typically, a week-to-week thing where I'll have a research day, spend a lot of time on writing, spend a lot of time answering emails with my collaborators, and then other days it's seeing patients in clinic.
Okay.
So it's kind of a combination.
Yeah. So this is a podcast about leadership, and one of the kind of examples of leadership that I'd love to dive in with you is you've been a co-investigator on the college-level aging athlete study, which I understand is a big collaborative, big team involved. What is your approach to kind of taking on a leadership role across a bigger team like that?
Yeah, well, I think the number one thing you can do is hire good people. I'm learning as an early career investigator, just trying to build a lab and be a leader in that space. To be available for all of your team members, but also really to foster an environment where we're all working toward the same goal. And science is not just about the principal investigator. Science is about the entire team. And we need to be able to all be on the same page about what it is that we're trying to accomplish. So, we have to have good communication skills. That's like the number one thing I would say is like my approach is trying to be good communicators. Really try to foster that like good team collaborative environment. You try to make things more fun. It's not always fun dealing with patients with dementia all day. I mean, it can kind of wear on you as an investigator and also a team member. Like we generally just see patients, when you talk about dementia work, you tend to see them get worse over time for a lot of patients. So we're trying to, keep things fun and keep things light, but it always can be a little bit hard to see people get worse over time. but we all are on the same page about what it is we're trying to accomplish.
Okay.
Yeah.
And can you talk a little bit more about, well, I guess first of all, what the athlete study has entailed? Does it interact with your other lines of research? And then kind of back to the leadership side,
Yeah.
like what have you taken from your experience on this study
The cleat
and taken
study.
into your, in the collegiate study and taken into your other areas of research?
Yeah. So the cleats, it was a project that was started actually when I was a postdoc. So I was at the time trying to really help the PI, Dr. Monroe Cullum, who's a mentor of mine, really develop the protocol.
Okay.
And so I got to be really more involved in that process and took the leadership role on that. So, and when you're doing that, you have a lot of responsibility in terms of making sure that you are helping your the other team members who are going to be designing and like putting it all into REDCap, and the people that are actually doing the work to make it happen. That we're all on the same page about what it is we want to include in there. So the communication skills are definitely there. But also, from a team member's perspective, everyone has their own role. And my role is to make sure that we're going to comb all of this research on all of these different risk factors so we can make sure we're not missing anything.
Right.
So when the study is really kind of running itself in a lot of ways now, once it's been off the ground, we have a good group that has really put the protocol in place, and people literally click on a link and do the survey study.
Okay.
And so they can answer it, and then all this database, now it's all set up where it just goes into this big database. And we can periodically pull data out of that and test hypotheses for it. But the second part of it is patients they call in for a cognitive screening over the phone. So that's been a good way for us to keep it remote, because actually, believe it or not, most of our participants now are outside of Texas. We have
interesting.
About 800 participants, and like 60% of them now are outside of the state.
Why do you think that is?
I think it was social media blasts. Just in general, it kind of caught more. I mean, we think about, on a national scale, like obviously Texas is the most represented state, but we have a lot of like out-of-state participants now, which is great. But yeah, we because of the nature of the study, you don't have to come in to do anything in particular. It can all be done over telehealth, which is great. But from a leadership perspective, I think you learn that doing things on the front end and taking more time on that perspective, like just from the process of it and being really methodical with your team and communicating with your team, pays off more in the long run.
Right.
Because if there's something that's inefficient about that process, it makes the whole team suffer, right? So you have to have good communications about what's going to be easiest, and is this piece of data, is this measure that we're going to add, is that really necessary for the question we're trying to accomplish? And, is it going to be worth the time for the participant and for our team members to really do it?
Totally.
Yeah.
And how do you think about teaching and mentoring kind of the next up-and-comers in this space, in research or in patient care, things like that?
Yeah. Well, I'm really happy to have a little experience in doing a little bit of all of that. Because of our graduate program, we have students that come in, like doctoral students that come in, and also interns that come into our clinic for both research mentorship and also clinical mentorship, and part of their clinical training. And so we get to supervise them and all aspects of that, which is really, I find, very rewarding experience. We also have the opportunity that most academic medical centers don't have, and we get to teach graduate courses if we want. And so that's always been a good experience too, to actually teach subject material. So we do a little bit of mentorship and all those things.
Absolutely.
And it's one of those things where you learn more as you get more involved. I'm a third-year faculty member, and you start to find your own kind of mentorship and supervisory style.
Yeah.
That's a little different.
How would you describe your style?
I'm probably a little bit more laid back than most of the neuropsychologists, I would say. We tend to be kind of a type A bunch, so to speak.
I could see that.
Yeah, we're like very data driven, and we're very particular about how the standardization of how we do these tests and do these measures. But I think you have to. I think the number one thing that I took away from my own mentors and my own clinical training and research mentors is you have to meet students where they're at. And you first have to sit down and listen, like, what are your goals? What do you want to do? Because not everyone wants to be a researcher. Not everyone wants to be, in the same way, not everyone wants to be a full-time clinician. Right? So you have to understand what is it that they're trying to accomplish too, and what could you offer them to kind of help that goal succeed. So I think that's first actually sitting down and talking to the student or mentee of what it is they want to accomplish. And their goals might change over time, so you have to kind of keep up with that. I was one of those that also had changing goals. I was going to be a clinician, and I kind of fell more in love with research and started and kind of shifted to that. So, you never quite know where that's going to be or kind of where you're going to end up. And so taking those opportunities as they come to and kind of imparting that knowledge, knowing that a first-year graduate student who comes into you, they don't know what they don't know. They don't know what they want quite yet because they haven't had experience with it. They might find a patient population that they love, right? And so they want to work with that. And I think that's probably true of not just neuropsychology, but also other medical fields as well.
Okay. And what's your advice to young scientists who maybe have a big, ambitious research goal and they're trying to figure out where to start or apply for their first grant?
Yeah. Well, internal funding is a great way to start.
Okay.
So, you always, and you get 0% of the funds you don't apply for. So,
very true.
But you have to pick your battles too. And that's where your mentors come in. When you're trying to first get funding, you have to, you really try to cast a wide net, but you also don't want to be applying for everything so that you're not productive in other things, right? Because if you have a very low chance of getting funded in something, it's probably not worth your while.
I imagine writing grants could be a full-time job.
It is, yeah. It always takes longer than you think.
Yeah.
And I'm learning that too as you kind of embark, more on new grants. It takes longer to write them than you think, and it gets easier over time. But scientific writing is different. Grantsmanship is different than manuscript writing, and it's different than clinical writing, and it's different than all the way down to emails.
Yeah.
So your writing changes obviously a lot. But yeah, it's for early career folks, listen to your mentors about kind of where you should be dedicating your time. And it's okay to kind of reach out for things and see if, certain areas are more interesting to you than maybe you, let me should say it this way. It's okay to follow lines of research that may not be quite in your mentor's wheelhouse, too.
That's a good point.
Maybe it's adjacent to that, but you also need to be able to separate yourself a little bit from your mentors as well.
Right. So speaking of mentors, there's a question that we always ask our guests on Learning from Leaders. Who has been a mentor in your life that has really helped you shape your view on leadership, on how you think about your career, and so on?
Yeah, I think I have two that really come to mind just from a professional standpoint, and they're Monroe Cullum and Laura Lakritz. So they are both neuropsychologists. They're senior neuropsychologists at UT Southwestern. And Dr. Lakritz was absolutely critical on the professional development side of trying to help students take the next step. We have didactic training, and we have internship training, and we have postdoc training. And so she was very helpful, and she also, recruited me to stay on too. So that was very.
So we have her to thank.
We have her to thank, for that. And so she's absolutely great, and she really is very passionate about professional development for anybody who comes in her office, really, whether it be a student, intern, postdoc, or our faculty.
Yeah.
And then Dr. Cullum has really been, Monroe Cullum has really been instrumental on the scientific side. He's always believed in my work, and he's always provided really good feedback. And he does a good job of meeting people where they're at, and not trying to confine students and mentees into one area of research. I've feel very fortunate. He kind of took this career of also having kind of broad areas of research that kind of narrowed over time. And he just really enjoys doing research, and he's a perfect person to try to help students kind of connect with other people, other faculty members across the institution, to really kind of try to develop lines of research for students and faculty.
Well, they both sound like incredible mentors.
Yeah, they've been great.
And I can see how you would be an incredible mentor to so many of these up-and-comers. So before we wrap up, we have a quick rapid fire.
Okay.
So just first thing that comes to mind, first of all, favorite sports team?
Detroit Tigers.
Okay, that was quick.
Close.
That might be the fastest.
Not even close.
That might be the fastest rapid fire we've ever gotten.
Yeah, we're in a bad spot right now with our ace pitcher, trying to figure out if we need to trade him or try to sign him. But we're kind of a mid-market team trying to play with the big boys right now, and so that's been tough. And second is the Lions for sure, which we had a good game last night against your Cowboys. So
okay. Next, what is one brain health habit that you practice daily?
It's kind of a do as I say, not as I do kind of situation. We have a home gym in our garage that we developed when all the gyms closed for the pandemic, my wife and I, and so we try to get out there multiple times a week to actually exercise. We have 2 young kids who also need to get to school at very early times nowadays, so it's a little bit more challenging than it used to be. But I would say that's trying to stay active and move is a good brain health habit that I practice. Totally. The other one that doesn't really count is like staying mentally stimulated and mentally, so you're not just like, so you're doing things, learning new things every day,
right? Which
in a job that I have is kind of a prerequisite.
Yeah. Totally. What is your go-to lunch spot near UT Southwestern?
Probably Maple and Motor.
I've never been.
Oh, really? They're really good burgers. It was like an old mechanic shop they turned into a burger joint. Yeah, a burger diner joint.
What do you get there?
Just a normal cheeseburger and fries. I don't get to go there nearly as often anymore, but they also had, we used to be in the old Bass building, which used to be like a lot closer to it versus moving. So they are now putting a new hospital there. So
okay. I mean, nice to have the new hospital.
Yeah, it's very nice to have the new hospital. It sounds like a good move.
Yeah. Okay, what TV show are you watching right now?
Right now we're watching The Pit, my wife and I.
So good.
Yeah, it's really good.
And how realistic is it?
Well, I have never been in an ER setting ever in my training. There's not.
You've been far closer than I have.
Yeah, we did do some psychiatric at Parkland as part of our training. We had a psychiatric emergency room kind of rotation where it's triage, and it's accurate in that sense. They haven't depicted a lot of psychiatric emergencies or anything like that, so too much on the show so far. So, but from what I hear, it seems to be accurate. It's kind of one of those things you only can watch a couple episodes, and then you got to calm down a little bit.
I feel that for sure. Okay, if you weren't in your current career, what would you be doing?
Yeah, people have asked me that before. It's a really hard question to answer. I have a lot of hobbies. I think I tried to, let me put it this way. I have a lot of hobbies, and I would probably try to do something in the athletic space. I don't quite know what that would be, whether that be, I decided to go to graduate school instead of giving minor league baseball a shot, which I probably would have washed out, and those guys are incredibly good, way better than I ever probably could be playing baseball, so it's probably the right choice. So maybe it would have been coaching, in baseball or something in the baseball space. But honestly, I'd also given thoughts of being a chef at some point.
Oh.
Yeah, I like
Do you
cooking.
cook a lot?
I do like cooking a lot. But the restaurant grind is absolutely insane, according to other chefs I've talked to. So I think I like the home chef kind of cooking.
That
for
sounds
enjoyment.
Like the right version.
And for enjoyment rather than as a career.
Yeah. Okay, what is your secret brain fuel? Coffee, tea, an energy drink, or something else?
Yeah.
Okay,
Coffee.
Me too. I'm an addict.
Absolutely, yeah. I got my wife a Breville Bambino espresso maker for her birthday.
That sounds incredible.
Yeah. It's I wish I could work from home more. Let's put it that way, for the afternoon cup of coffee.
Yeah.
Yeah.
Okay, if you could instantly download one new skill into your brain, Matrix style, what would it be?
I think it'd be kind of like, I probably have two. I think it'd be cool to speak any language at
Okay.
any time.
And okay.
Like just being able to, including software code and computer language.
Oh, that's cool.
So like
Yeah.
I would say like all aspects of like just being able to understand and be fluent in every language, I think would be a very helpful skill. The other one I would say, selfishly, is just being able to, like, there are some people out there that I envy because they can just literally think about something and write it once. And it's like great.
It's astoundingly impressive.
And
when people
versus
do that.
having to edit
Yeah.
multiple times. And so if I had like from my own like career standpoint, if I could just be able to just think about something and write it once and
That would
finally
save a lot of time.
get to the end product before I have to edit it all, that would be great.
Yeah. And then you can do that in all of your languages.
Yeah, of course. Yeah.
Okay, are you more likely to binge a sports documentary or a psychological thriller?
Thriller.
Okay.
Yeah.
Do you have a favorite?
Unfortunately, they canceled it, but it seems like maybe a new season's coming back. But I really liked David Fincher's Mindhunter on Netflix.
Okay.
I sort of have this dark fascination with like the dark side of psychology,
Yeah.
which I mean, as a clinical psychologist, I kind of always kind of wondered about human behavior, and so that was a really good psychological thriller. And so, yeah, I'm much more willing to do that than a sports documentary. Yeah.
Okay, so this is the last question. If you could study the brain of any historical figure, who would it be?
I'm not sure I have a great answer for that.
Or current figure?
This is kind of a cop-out because the brain was probably more studied than anybody's in human history, but HM, the famous patient HM, who underwent bilateral hippocampal resection before they knew that it was an experimental procedure, before they really knew that those regions are critical for memory formation. And he's probably the most studied brain of all time, and they learned so much about how memory functions through his particular situation. But yeah, going back in time and being a part of that research team and kind of undergoing that discovery would have been pretty fascinating.
That would be fascinating.
Yeah, pretty fascinating.
Wow. Okay, well, thank you so much for being here
pleasure.
today. It's been so fascinating to hear about all of your research and your work, and congratulations on what sounds like an incredible year specifically
Thank you.
for your grant funding and all of your efforts. And thank you for everything that you're doing for our community and at UT Southwestern. So really appreciate you being here today. And to our listeners, thank you so much for joining us and learning from leaders.
Thanks for listening to Learning from Leaders. If you enjoyed this episode, we invite you to subscribe now for monthly episode drops so that you can continue to learn from experienced business and community leaders to help you drive meaningful change in your community.